A useful automation is the automatic beam column joints. Modeling beam column joints in handwritten TCL files is cumbersome because the user needs to build several components for each joint, such as duplicated joint nodes, duplicated beam column nodes, rigid links, and nonlinear rotational springs. With STKO's automatic beam column joint tool, the user can simply assign a joint material model to a node of the structure, and STKO will automatically create the beam column joint assembly. The Python API in STKO allows users to add new and custom components. As OpenC's is an open source code, users often wish to extend their own OpenC's version with custom components such as material models or elements. With the Python API, users can make their own custom components accessible within STKO. The Python API is also useful for creating automations such as the distributed absorbing boundary conditions or the beam-to-solid bar slip, as demonstrated in other videos in this series. Automations are great for converting lengthy manual operations into well-structured pipelines. Finally, the new Python script editor, available from STKO version 2.0, will allow users to directly access the post-processing database, enabling them to interact with the results, query existing results, or even create additional custom-derived results as a function of existing results. For example, here is a model of a T-beam made with fiber cross-sections showing the damage variable. In the post-processor, to view alternative results, you can open the Python script editor and use it to compute derived results. In this example, we ran a script to view the critical damage, and the new results can be immediately viewed in the post-processor. Sign up for your 1-month free trial of STKO today. Just head on over to our website and register, download the software, and start modeling.